Hello and welcome to my channel. I am Ensign Augustine. I welcome you to my lesson 2 on Calculus 1, Differentiation. If you not watch my video on lesson 1, just check the description for that video. It will help you to understand a lot about differentiation. In this tutorial, we'll be looking at how to use the chain rule. How to use the chain rule to differentiate polynomial functions. So join me as we go through. I will take a lot of examples to help you understand everything about using the chain rule to differentiate polynomial functions. So let's go through. Take your time, wait, watch as we do the chain rule. Now you know that if we have f of x equal to x equal to u exponent n, where u is a function of x, meaning that this u contains x, then the derivative of f with respect to r, x is given by du on dx dot df on du. Very simple as that. So that du will cancel du and you have df on dx. Very simple as that. Or let me write it. If I have y is equal to u to the power n, where u is a function of x, then dy on dx is equal to du on dx times dy on du. That is, you break u with respect to x that it contains and you multiply it by dy on du, so that the du will cancel du. That's why we call it a chain. So you see that there's a chain here. Very simple as that. So now let's take a few examples, and these examples will help you very well. So just stay calm and enjoy mathematics. But remember to subscribe to my channel. Now let's take examples here. Now first example, we are going to consider differentiating y is equal to the square root of 4x cubed minus 3x squared plus 5. How do we differentiate this? So here, let us write this in the form y is equal to u to the power n. So we are going to have y is equal to 4x cubed minus 3x squared plus 5, all to the power half. Very simple as that. So we let u equal to the inner function. So here we write let u equal to 4x cubed minus 3x squared plus 5. Then this implies that y is equal to u to the power half. So let's differentiate u with respect to x. So we have here du on dx is equal to 3 times 4, 12x squared minus 6x. And the derivative of constant is 0. And now here we have our dy on du equal to half of u. You subtract 1 from half, you get negative 1 out of 2, which is the same as half of 1 divided by square root of u. Watch the video on lesson 1, you will understand how this is done. So this is equal to 1 divided by 2 square root of u. By here you say u is equal to all these. So let me bring it here. Therefore dy on du is equal to 1 divided by 2 times the square root of 4x cubed minus 3x squared plus 5. So we are good to go. Then the derivative of y respect to x is given by the derivative of u respect to x times the derivative of y respect to u. And this is given by 12x squared minus 6x times 1 divided by 2 times the square root of 4x cubed minus 3x squared plus 5. Wow. So how do we do this? Here we can factorize 2 out here. So here this is the same as 2 times 6x squared minus 3x times 1 divided by, oh, let me bring it here rather. This is equal to 2 times 6x squared minus 3x times 1 divided by the square root of, 2 times the square root of 4x squared minus 4x cubed rather, minus 3x plus 5. So these two will cancel these two, and you have our answer as 6x squared minus 3x divided by the square root of 4x cubed minus 3x plus 5. So as you follow, you learn the techniques, how to simplify the algebraic expressions, and then how we move about it. That is the most important thing. You may not get the same questions in your exams, but watching how the simplification goes will help you to do yours. So let's take another one. So that is our dy on dx. You see, very simple as that. So this is our u, and then we have y equal to u to the power half. Very simple. Let's take the next one. The next one that we are going to take is very simple. We are going to take y is equal to 5 divided by x minus 2. So this is the same as y equal to 5 times 1 divided by x minus 2. And this is y equal to 5 times x minus 2 to the power negative 1. Very simple as that. I've told you to watch the first lesson from the description. It will help you to understand this. Okay, so here we have y to be equal to, okay, we've broken it down, so let's write you let u equal to the inner function, that is x minus 2. This implies that y is equal to 5 times u to the power negative 1. Very simple as that. So here we are going to have, this implies that the derivative of u with respect to x is equal to if we differentiate x, you get 1. If we differentiate negative 2 is a constant, you get 0. And here, derivative of y with respect to u will give us negative 1 times 5, negative 5, u to the power negative 2. And this is the same as minus 5 times u is x minus 2. So you have x minus 2 to the power negative 2. So here, the derivative of y with respect to x is equal to the derivative of u with respect to x times the derivative of y with respect to u. And this will be given by 1 times minus 5 times x minus 2 to the power negative 2, and this will give us minus 5 divided by x minus 2 all squared. I've told you to watch a lesson 1. I've done how to simplify all this, but for the sake of x minus 2 to the power negative 2 is the same as x minus 2 all squared to the power negative 1. That is the loss of exponents. Because if I multiply negative 1 by 2, I'll come back here. And I factorize negative 1 out because I know that negative 1, that is a to the power negative 1, is the same as 1 divided by a. So this one will give me 1 divided by x minus 2 squared. That is why I've done that. and I have minus 5 multiplying. So the minus 5 will multiply the 1, and I'll come back to this stage. Very, very simple. I said you should keep watching. I'll reveal more secrets here and how to use the chain rule. Now let's take another example using the chain rule again. So in this one, we are going to take a very nice one here. We are going to take y equal to, we are going to take y equal to, we will be taking y equal to, we will be taking y is equal to 3 divided by 4t squared minus 5t. So the same way we have y equal to 3 times 4t squared minus minus 5t all to the power negative 1 as we've done earlier. And here you let u to be equal to 4t squared minus 5t. And that here we have y to be equal to 3 u to the power negative 1. So here our du on dt will be equal to 2 times 4, 8t minus 5. If we differentiate minus 5t, you take minus 5 because t has power 1. And here, if we take dy on du, we're going to get negative times 3, that is negative 3. We take 1 from this, you have negative 2, which is the same as negative 3 divided by u squared. And it is the same as negative 3 divided by u. U is 4t squared minus 5t, so you write 4t squared minus 5t all to the power 2. Now, we are going to write the derivative of y with respect to t is equal to dy, okay, let me bring du on dt dot dy on du. So this will give us a du on dt is 8t minus 5 times dy on du is minus 3 divided by 4t squared minus 5t all squared. Very simple. And here, can we do some factorization here? No, we can't do anything. So we just do the multiplication. So the top one will multiply this. Minus 3 times 8 will give us a minus 24 plus 15 all divided by 4t squared minus 5t all squared. That is it. That is it. That is minus 3 times 8 is minus 24. Then t is here. Minus 3 times minus 5 plus positive 15. Very simple as that. So keep watching as I review more secrets. Now we are going to do a bit complex one than what we've done earlier. So let's take that one and see. Let's take that one. And that one I'm going to write I'm going to write this one. G of u is equal to 1 divided by the 4th root of 3u squared minus 2 all cube. This one too, we have to use the chain rule. So how do we use the chain rule to do this one? Before we use the chain, we have to put this in this form. So now let's move on. We have g of u to be equal to 1 divided by 3u squared minus 2 to the power 3 out of 4. Because this is because if I have a 4th root of a cube, this is the same as a cube to the power 1 out of 4. So 1 out of 4 times this will bring me here. And now this one is the same as 1 times 3u to the power 2 minus 2 to the power negative 3 out of 4. And 1 times this will give us that. So, okay, let me put it here. 3u squared minus 2 to to the power negative 3 on 4. Now we have u there again, so we are not going to say let u, we are going to take another variable. So we can say that let me say v to be equal to the inner function 3u squared minus 2. Now this implies that g of u is equal to v to the power negative 3 on 4. So here we are going to take the v on du is equal to 6u, 2 times 3 is 6, we take 1 get u. The derivative of a constant is 0, so we leave it. And we come here, we are going to have the derivative of d of u with respect to v is equal to, I have more space here, so let me bring it here. We have g of u to be equal to v to the power negative 3 on 4. So the derivative of g of u with respect to v is equal to, let me use this marker. We multiply this by negative 3 on 4. We write v to the power negative 3 on 4 minus 1. And this will give us negative 3 on 4, v to the power negative 7 on 4. And this is the same as negative 3 on 4 times 1 divided by v to the power 7 on 4. And this is the same as, let me use this marker. This is the same as minus 3 on 4 times v to the power 7 on 4. So yes, but what is v? V is 3u squared minus 2. So here, this is the same as negative 3 on 4 times 3u squared minus 2 to the power 7 on 4. Now, let's use the product rule. So we are going to get this. Let me write it here. We are going to get g prime of u to be equal to, we've found this one, du on dv on du dot the g of u on dv. So this will give us 6u times negative 3 on 4 times 3u squared minus 2 exponent 7 out of 4. And see that here 2 will go here 2 and 2 will go here 3. So 3 times this will give us negative 9u divided by 2 times 3u squared minus 2 to the power 7 out of 4. And we are done with the derivative. I hope this one also helps. Okay, let's take another example. Right? We are moving on. Remember to subscribe to my channel, and you can leave difficult questions at the comment section. Wow. So let me clean this portion. Oh, I've cleaned the formula. That's no P. Let me clean the board. Let's get the board. That is very, very necessary. Okay, let's take this one. This type mostly occurs whenever we are doing integral by parts. Whenever you are doing integral by parts, you get something like, let's say, y equal to 4 divided by 5 into bracket x minus 2 to the power 5 minus 1 divided by 5 into bracket 5x plus 3. Let me give it to the power 4. How do we find the derivative of y with respect to x? This is not integration, this is differentiation. So how do you differentiate this? So what we do is that we differentiate this term by term. So we take this one and we differentiate. We take this one too and then we differentiate. So let's simplify it first before we do the differentiation. So here y is equal to 4 out of 5 times x minus 2 to the power negative 5 minus 1 out of 5 times 5x plus 3 to the power negative 4. Very simple as that. So here, before we do the y dx, we have to take this one and use the chain rule to differentiate. And then we take this one to use the chain rule to differentiate. So let's break it. So for x minus 2 to the power minus 5, let us say that this is equal to a, and that the inner function is equal to u, that is u equal to x minus 2. Then we are going to take du on dx to be equal to positive 1. If we differentiate this, you get 1. If we differentiate this, you get 0. It's a constant. And that we have a equal to u to the power minus 5. And this implies that the derivative of a with respect to u is equal to minus 5u to the power negative 6. If we take 1 from this, you get minus 6. If we multiply minus 5 by this, you get this. And this will be given as minus 5 divided by u to the power 6. And this is the same as minus 5 divided by u is x minus 2. So you write x minus 2 to the power positive 6. And now we take our dA on dx to be equal to du dx, that is du on dx dot dA on du, dA on, do you see that here du will cancel du and get back to dA on dx, and this will give us 1 times minus 5 on x minus 2 to the power 6, and that will give us minus 5 divided by x minus 2 to the power 6. So this is the derivative of this one. So you come and put it back inside. Very simple as that. I hope you are enjoying the lesson. Now, so let's take this one here. We are writing here as dy on dx to be equal to, we have 4 out of 5 here already. So we put 4 out of 5 times minus 5 on x minus 2 to the power 6. So let's wait for this one and then come and put it here. Okay, so now let's take this one too and do the derivative. So here, let's say that we have v to be equal to 5x plus 3 to the power negative 4. And that we are writing m is equal to 5x plus 3. That's the inner function. So this implies that v will be equal to m to the power negative 4. So here, the derivative of m with respect to x is 5. 3 is a constant, so it will be 0. If we differentiate this as power 1, so we take 5. And we are going to have the derivative of v with respect to m is minus 4m to the power minus 5. Minus 4 times 1 will give us minus 4. If we subtract 1, we get minus 5. So this is the same as minus 4 times m is 5x plus 3 to 5x plus 3 to the power negative 5. So now we can find dv on dx. So we write here dv on dx to be equal to dm on dx times dv on dm. So here we have 5 times minus 4 into brackets. So let me use dot here. 5 times minus 4 into brackets. 5x plus 3 to the power negative 5. And this will give us negative 20 times 5x plus 3 to the power negative 5, which is the same as negative 20 divided by 5x plus 3 to the power 5. So we're going to put this back here rather. So here we have minus 1 out of 5 there already, and we are going to put negative 20 divided by 5x plus 3. Let me use this bigger one to the power 5. Wow! Now you can clean some part of the board. Very simple as that. So let me clean this part off. Okay. So here, dy on dx. Here, this 5 will cancel this 5. So you have minus 4 divided by x minus 2 to the power y. Is it to the power 6? Yes, it's to the power 6. Why? It's to the power 6. That's what we have here. And this will cancel this to give us 4. Negative times negative is positive. We're having 4 divided by 5 into bracket x plus 3 to the power 5. Wow! We've done that. Very simple as that. That is how we do the derivative for this one. So you see, we took this one, we took the derivative of this, and then we substituted the derivative back here. And then here too, we took this one, we found the derivative of this, and that is what we have. Now I said, you should keep watching for more secrets. So let's take this one too. Let's take this one too. Let's take this one. And what I have here is very simple. I have y equal to, into bracket, the square root of x plus 1 divided by the cube root of x all squared. Wow! This one too, we say that I will let u equal to square root of x plus 1 divided by cube root of x. How do we do the derivative of this? We've done this one in the lesson 1. So here, we write u to be equal to x to the power half plus 1 divided by x to the power 1 out of 3. So u is equal to x to the power 1 out of 3 plus, 1 out of 2 plus x to the power negative 1 out of 3. So here, du on dx is equal to half of x to the power negative 1 out of 2. And this half times this will give what you have. If we subtract 1, you get negative 1 out of 2. And this is minus 1 out of 3, x to the power minus 4 out of 3. Minus 1 out of 3 times 1 will give you minus 1 out of 3. Minus 1 out of 3 minus 1 will give you minus 4 out of 3. So here we have du on dx to be equal to 1 divided by 2 root x minus 1 divided by 3 times the cube root of x to the power 4. How do we do this? Let's do that one. Please watch lesson 1. It is very, very important. It will help you to understand all these, how we simplify all these expressions. So now let's take this one. Half 1 out of 3, x to the power negative 4 out of 3. So this is 1 out of 3 times 1 divided by x to the power 4 out of 3. So here you have 1 out of 3 times 1 divided by x to the power 1 out of 3. Then I'll bring the 4 out. Why am I doing this? Because I know that power 1 out of 3 will give me cube root. So 1 times 1 is 1. Then this will give me 3 times cube root of x. Then I'll bring power 4. So the power 4 can come here, or I can put this in brackets and then the power 4 will be there. Very simple as that. And this, the cube root has to come over. Yes. And then I'll put it in brackets, which is the same as 1 divided by the cube root of then 4 inside. So that is why we did this. And this one, you go through the same procedure and you go to that one. So now you find the u dx. Wow. Let's continue. You found the u dx. So let's find the rest. So here we are going to take this one. We are going to have if rating u equal to the inner function, so this implies that y is equal to u to the power 2, and here dy on du is equal to 2u, which is the same as 2 times root x plus 1 divided by the cube root of x. Wow. So now dy on dx is equal to du on dx dot dy on du, which is the same as du on dx is what we have here, 1 divided by 2 root x minus 1 divided by 3 times the cube root of x to the power 4 times 2. Okay, let me do this one. And then we have root x plus 1 divided by 3, the cube root of x. Very simple as that. Yes, so here these two will come out. So you're having 2 times 1 divided by 2 root x minus 1 on 3 times the cube root of x to the power 4 times root x plus 1 divided by the cube root of x. So we are interested in getting the derivative, and this is the derivative. If you want to move ahead to expand that one, you do the expansion. But for the sake of our time, let's leave it here, or we should expand. No, let's leave it here. Very simple as that. Let's leave it here. So if you want to expand, you multiply this one through this, and you go. Okay, let's do the expansion and see where you go. That one also take us through some small algebraic and then indices for you to build up that area. So let me clean this part. And then bring this one here. We have 2 times 1 divided by 2 root x minus 1 divided by 3 the cube root of x to the power 4 times root x plus 1 divided by the cube root of x. So let's do the expansion. So 2 is here, so let's put 2 there. And then we take 1 divided by 2 root x times root x plus 1 divided by the cube root of x minus 1 divided by, I think we should express this in the exponent form, but let's write it down before. 1 divided by 3 a cube root of x to the power 4 times square root of x plus 1 divided by the cube root of x. Yes, this will involve a lot of simplification, so let's move on. So here, if we multiply this by that, we are going to have 1 on 2. That is root x or cancel root x, because this one gives us 1 on 2 root x times root x, and that this will cancel this for us to get 1 on 2 plus 1 on 2 root x times 1 on the cube root of x. What are we going to get? So we are going to get 1 on 2 times root x is x to the power half. Then this one is also 1 divided by x to the power 1 out of 3. So what do? 1 will multiply 1, you are going to get 1. Then this 2 is there. Then you are going to multiply x to the power half times x to the power 1 out of 3. So we are going to add the exponents 1 on 2, 1 on 2 plus 1 on 3. And that will give us 5 on 6. So we are going to have x to the power 5 on 6. So we are going to have 1 on 2 x to the power 5 on 6. Very simple. So let's close the bracket. We've done this one, okay. So let's continue to this side. Okay. Let's continue to this side. So here too, we are going to have negative times positive is negative. So this 1 on 3 will come here. You have 1 on 3. Then we are going to have cube root of x to the power 4 is the same as x to the power 4 out of 3. And we are going to have this one. So we are going to divide. So we are going to divide it by x to the power half. Very simple, because when this one multiplies, 1 will multiply this, it will come to the top, and this one will come under. It will be of this form. This divided by 3 cube root of x to the power 4, which is the same as x to the power half on 3, x to the power 3 out of 4. Sorry, 4 out of 3. So what do? This is the same as 1 on 3, x to the power 1 out of 2 minus 4 out of 3. And here, what are we going to get? Let's take 1 out of 2 minus 4 out of 3. The LCM is 6. So this will give me 3 minus 8, and that is minus 5 out of 6. I hope I'm correct. Yes. Or 2 will go here, 3 times this will give you 3. 3 will go into 6, 2 times this, so I'm correct. So we are going to have times x to the power minus 5 out of 6 at the top. Very simple as that. And I will left with the last one. And we take the next example. So let's take what we will look at and then see. So we are going to have this one here. That is negative times positive is negative. And then we having 1 times 1 is 1. Then 3 will come under, so you write 3. And now this one will multiply this. So we're going to have x to the power 4 out of 3 times x to the power 1 out of 3. So this will have x to the power 4 out of 3 plus 1 out of 3. That will give us x to the power 5 out of 3. Very simple. So you put x to the power 5 out of 3 here. And we are done. Okay, so here let's multiply 2 by the 2. Let's multiply 2 by the 2 and see what we are going to get. So here, 2 times this will give me 1. 2 times this 2 will come and cancel this 2, so I have plus 1 on x to the power 5 out of 6. 2 times will give me minus 2 on 3, x to the power minus 5 on 6. 2 times this will give me minus 2 on 3. Then I have x to the power 5 out of 3. Okay, we are still going to simplify. This will give me 1 plus 1 divided by x to the power 5 on 6 is the same as the 6 root of x to the power 5 minus 2 on 3 times the 6th root of x to the power 5. That is what you are going to get. Minus another 2 on 3. And this will give us the cube root to the power 5. Very simple as that. So this is what we are going to get after the expansion. So you see that this one is the same as writing x to the power 5 out of 6 to the power negative 1. I've done this in lesson 1. And here, this is the same as x to the power 1 out of 6 to the power 5 or to the power negative 1. So this will give me the cube root, so the 6th root of x to the power 5 to the power negative 1. And this will turn to 1 divided by the 6th root of x to the power 5. So that is how I used to do my simplification. Very simple. I hope you are enjoying the lesson, and the simplification also has helped. Yes, because it will help you in other areas where you are to simplify these expressions. That is why I took my time to simplify. Now let's take another example. Now this example will also contain a very nice one, and then after that we will say we are done. So let's take this one. I have y equal to 2 divided by the 5th root of x squared minus 6. This is the last one that we are going to take, and we are done. Okay, so this last one does not contain a lot. So here we have y to be equal to 2 divided by x to the power 6 minus 5, x squared minus 6 to the power 1 out of 5. And this is the same as 2 times 1 divided by x squared minus 6 to the power 1 out of 5. And this is the same as 2 times x squared minus 6 to the power negative 1 out of 5. And we are good to go with the chain rule. Okay, so what will the chain rule give us? Let's see. So we are going to have y equal to 2 times x squared minus 6 to the power negative 1 out of 5. So here we will let u to be equal to x squared minus 6. And we have du on the x equal to 2x. Very simple as that. 2 times 1 is 2. If you take 1 from this, you get power 1. And now this implies that y is equal to 2 times u to the power negative 1 out of 5. And here, the derivative of y with respect to u is equal to minus 2 divided by 5. That is minus 1 out of 5 times 2. You have minus 2 divided by 5 times u to the power negative 6 on 5. That is negative 1 out of 5 minus 1 will give us minus 6 on 5. So this is the same as negative 2 on 5 times u to the power positive 6 out of 5. Very simple as that. And this is the same as negative 2 divided by 5 times the 5th root of u. And what is u? X squared minus 6. So I have x squared minus 6 to the power 6. Wow. Very simple as that. U is x squared minus 6. So I've put x squared minus 6 here. And I have to the power 6. So I've brought to the power 6 there. Now, that is dy on du. So you have du on the x and you have dy on du. So we can write the derivative of y respect to x is equal to the derivative of u respect to x times the derivative of y respect to u. I have enough space here, so let me put it at the top here. So this will give me what? 2x times negative 2 divided by 5 times the fifth root of x squared minus 6 to the power 6. And 2x times this will give me minus 4 divided by 5 times the fifth root of x squared minus 6 to the power 6 as my dy on dx. So that is that for the chain rule, and I hope this lesson will take you far. Thank you for watching. I'm Mesa Augustine. You can follow me on my Facebook page, Maths with Vim. If you have any difficult question related to this, leave it at the comment section and I'll be of help to you. Bye bye.